Welcome, ladies and gentlemen. Now we're looking at working with trig functions on the unit circle. Leading into that, let's get right into this problem. The given point lies on the terminal side of an angle theta in standard position. Find the values of the 6 trigonometric functions of theta. So the coordinate that we were given is negative 8, 5. So as you see here, we plotted that point, negative 8, 5, and from that point we made a right triangle. So we can see that from the origin here, as we go along the x-axis, we stopped at where x equals negative 8. Then we went down to where y is equal to negative 5. And so we use that coordinate to make this right triangle. We have the unknown angle theta. Now in order to find the hypotenuse, because this is a right triangle, we had to use the Pythagorean theorem. So in this case, the hypotenuse, which is referred to as r, is represented as the square root of x squared plus y squared. So we're using the Pythagorean theorem to find that hypotenuse. So we take those values of x and y. So in place of x, we substitute negative 8, so negative 8 squared, plus in place of y, we substitute the negative 5. We square it. Now as I'm doing this, you should pause the video. You should have pencil and paper. You should be writing these formulas down, and if you need to do so, you should pause it and work this out through its entirety, because if you just sit here and watch the video and don't have pencil and paper, this instruction is not going to do you any good whatsoever. So you should be working along with the video. So now we know that negative 8 squared is 64. Negative 5 squared is 25. We add that together, so r in radical form is equal to the square root of 89. So now we've listed that in here again. We've just recopied the diagram. So the hypotenuse is the square root of 89, and as you notice here, I have the sides listed. Well, where y is equal to negative 5, that is opposite, and I'm going to label that as well. This is opposite angle theta. So here's angle theta. So this side is opposite that angle. Where x equals negative 8, this is the adjacent side. So now we're going to use the information from this right triangle to do the 6 trigonometric functions. So what I'm going to ask you to do before I move on is to stop the video, use this right triangle, and now the measurements we have here, and list all these 6 trigonometric functions. So let this be like a check for you. Work out the problems and then turn the video on to use this to check your understanding. So please pause the video right now and use this right triangle to write the 6 trigonometric functions. Please pause the video now and do that. Alright, I'm assuming that you paused the video and that you did as I asked. So let's take a look at these 6 trig functions. So from the triangle, we had that the sine of angle theta is negative 5 over the square root of 89, the opposite over the hypotenuse. We rationalize the denominator by multiplying top and bottom by the square root of 89, and we get minus 5 times the square root of 85 over 89. And now we know that the cosecant is the reciprocal of the sine. So using this first fraction here, the cosecant in its rationalized form is minus the square root of 89 over 5. Now again, when you go back and you look at the triangle, now the adjacent side is where x equals negative 8. So the cosine of that angle is negative 8 over the square root of 89 but then we write that in its rationalized form. So we get negative 8 times the square root of 89 over 89. Well, the secant is just the reciprocal of the cosine. So the reciprocal of the cosine is minus the square root of 89 over 8. Now let's come back and look at this again. Now we're looking at the tangent. The tangent is the opposite side over the adjacent. So the tangent for angle theta is equal to negative 5 over negative 8, but that's 5/8 because negative divided by negative is positive. And here we know that the cotangent is the reciprocal of the tangent, so the cotangent of angle theta is 8/5. Ladies and gentlemen, that concludes this particular portion of the video instruction. Please let me know if this instruction was of help to you, and I hope that you pause the video and work through the problems before going on. That is the most effective way to do this. Please have an outstanding and fun-filled day. This is your teacher and instructor, Mr. Joshua Davis. Thank you for joining me.